Yes, starting part 2 soon. Very, very soon. Are we up? Why is Twitch not playing? Hello. Okay. So let's put starting in 5.33 minutes. I don't know, now it's like 3.33 minutes. Something like that. I don't know. I don't know how many minutes it is. maybe we're starting in 1.11 minutes now. One point one one minutes. Okay. This morning, I did a stream for about 2 hours, and at the start of the stream, the goal was to implement a good compile time error checking system that would, start looking for some of the errors that I commonly make, and the goal being not only to report errors for myself, but to provide a standard library, like the nugget of what will eventually become a module in the standard library that people can hook into that do this sort of thing for them. And also to sort of prod at certain portions of the language syntax, because you could say, as I said in the previous stream, every language has a different syntax, and every syntax has strong points and weak points. And what I want to do is test the weak points and say, like, okay, this syntax encourages a certain class of mistakes, or not encourages, but doesn't prevent a certain class of mistakes, certainly. And then the question is, can that be overcome with this kind of error checking, which I think it can. And then whether that's true or not sort of has implications about what the design of the language ultimately should be in the final form, right? So the goal is to try and work toward some of these things. So examples were, well, a thing that most languages that have, some descendant of the C printf, we want to ensure that we have the proper number of arguments for a given format string in cases where we can check that at compile time. The problem with that, of course, is that if you start internationalizing your program, your strings may not be available at compile time, and then this won't come into play, but we also can check at runtime. I'm actually going to write on here runtime print check. So I wrote print really early in the history of the library, and we didn't have a good logging facility or anything at that time, and so I don't do any kind of runtime logging, but we could certainly do runtime logging where we say, look, buddy, you didn't pass enough arguments, right? But the point here is to not require a runtime catch, because you may not have coverage of that code. Like if you don't go through a certain branch of your code, then you won't see that logging error. And you also don't want to wait for your application to start up and stuff to know that you made that mistake. So that's the point of this. So that's one thing that we're going to check for. And then, maybe we look for some of these other problems that we'll explain when we get into them. So we started to do this earlier today. I ran into a compiler bug. I think 2 bugs. I don't remember very clearly now. Fixed that bug or 2 bugs. And that video will be up on YouTube soon. Today we're actually going to proceed with what we were doing, which is here, in process build events, we loop around and we get messages from the compiler about what it has compiled. And if we have enabled this do error checking, which is enabled right now, then we call a routine called do error checking on everything that the compiler tells us. And now we're writing do error checking. And here we're just saying, look, if some code is type checked, then if it's a procedure, do this stuff. Now, there may be another compiler bug. Let's see. So I suspect actually that we're going to have a bug where things are not flagged as procedure bodies, and that this will not fire anymore. So I'm going to comment out this print, and I'm going to see if this ever fires. I suspect it doesn't, in which case we have to turn off this flagging for now, which shouldn't matter. We should still be able to implement the functionality without checking this flag, but like given that the previous stream was derailed by compiler stuff, I don't want to do that this time too. I want to actually move forward, and I would just put this on the list for later. So let me just see. Yeah, so that doesn't ever happen, but maybe if I comment this out and we check all the notes, there we go. So it does happen. So just this flag is not getting set, or it's getting set on the body, but the notes are on the header, which seems likely to me. So maybe that's actually not technically a compiler bug. It's something that I need to think about. I'll make a comment here. Investigate what is going on here. Either A, oh, actually, let's just do this. We should see hell of that all over the place if the flag actually works. We don't. Okay. So forget that. I don't need to put a comment here. Waiting on procedure body flagging fix. Maybe we'll fix that later today after we make some actual progress on this system, but for now I'm just going to put here this reminder that we need to do that at the top of that file. All right. So, for now, I'm just not going to flag anything print like that's not a procedure. We could check it in other ways. Like we could check the expression, the node type to make sure it's a procedure or whatever. But the reason this flag is there is to be convenient. And so we're just going to fix the flag later. But in the absence of fixing that flag, we're just checking print like on anything that's flagged print like. And as a review of that, we went through all these routines. So, we tagged print as print like and tprint and sprint and all that. And what print like means is that we have a varargs of any as our last argument. And the argument before that is a string, and that's going to be the format string. Now, I think we should maybe start. Oh, I'm checking the wrong thing anyway. This is fine, so it's progress. But so, when I look for this note on something and say that it's print like, what I'm getting is these guys. But these are not the guys that I actually want. I want the bodies of all procedures, and then I want to check their content for calls to these guys. So we're going to have to do something a little different. I am going to have to check for a procedure here, and I'm going to do that a different way to work around the fact that this flag isn't there. I'm going to say, so we have this code node right here, and on every, so we can check if something's a procedure because procedure is one of these items of the syntax tree, right? This code node, we get one of them for each thing in the syntax tree, and when we get this declaration, we have a root expression, which is a code node. So for a procedure, this will, I'll show you. So if decal.root expression and decal.root expression.kind is equal to code node.kind.procedure. If that's the case, then we're going to say check print calls on decal. Yeah. So we're going to change this to call check print calls. So in addition to that root expression, so you could imagine that we would have to navigate the tree, the syntax tree, by following all the links. But I do a thing to let people be lazy, which is that I flatten out these expressions into an array. So what I actually can do is the following. I can say for decal.expressions, so we're going to visit every expression, and if it dot kind is not equal to code node.kind.procedure call continue. So we're just going to look for every procedure call inside this procedure. And then I'm going to say call is cast code procedure call it. Right? So that's one of these. And the procedure expression is now the question is, what do we do? So we want to look for things that are identifiers. There might be, so usually if you do a procedure call, you'll say print, which is an identifier, right? And then some arguments. So for example, check print like here is an identifier. There's other things you could have on the left, like you could explicitly write a lambda there and somehow, you can't actually tag that as print like right now because that has to be on a declaration, but you might be able to do it later. But for now, we're just going to say if it's an identifier, we pay attention. So if call dot procedure expression dot kind is not equal to kind dot identifier continue. Okay, so it's called ident, not identifier. I don't usually abbreviate things, so I don't know why I did that. All right, here we get the name and the resolved declaration. And then some other things. You know, just because I like to pause for a little bit and make sure things are working, I'm going to say print procedure call to ident whatever, and then we'll print the file name and line number, because we're going to need that later anyway when we report errors. So ident equals cast code ident call.procedure expression and ident.name, and then the base here has file name and line number. So ident.file name, ident.line number. So let's see if that works. No, it totally doesn't. Huh. Well, let's find out why. Do we get here? Yes, we do. Do we get there? No. What? What? That's crazy. My suspicion is we may have to do more compiler debugging here. which I didn't want to do. My suspicion is okay. If decal expressions that count is greater than 20, print big decal. I bet this never fires, maybe, or very rarely. No, well. So what I'm trying to do is figure out if I'm getting procedures and I'm failing to recognize them, or what. So let's just see. Let's print out one of these. So if expressions.count is high, then that means that this declaration is a complex thing with lots of syntax tree nodes. Oh, no. Okay, let's see what some of these are. None of these are super long. Let's pick one at random. So panel 504. Sokoban, source, editor, panel 504. I feel like that's the header for the procedure. So I feel like what's going on is we are not ever... The problem isn't that the compiler is not flagging things as procedure body. The problem is we're not ever sending messages for procedure body anymore. So we're going to have to do compiler debugging again. Oh boy. Oh boy. So, you know, the thing that we're getting here is we're seeing this because it's a procedure with a lot of arguments, and that gets serialized into one of these arrays of expressions. And so the header of it, so every procedure goes through the pipeline in two parts. There's one that's just the header, and then there's one that's the body. And the reason for that is because, you know, the body may be complex and have many dependencies, but usually the header is a lot simpler. And if you force every procedure to wait on a body in order to compile your program, then you'll be unable to compile it because of like mutual recursion and stuff. So we let the headers pass through first, and that, well, let's verify this theory that we are never passing bodies as messages. So here we say do export on every top level declaration, and I'm going to put one here and say conditions is body. And I bet, oh, really? Really? Maybe I was wrong about my diagnosis. Wait. Queued, yeah. So expression. Okay, this is a built-in, this is not a real procedure because its line and character number are not set. This is, let's see what it is. Pre-main. This is the pre-main procedure. Okay, no surprise that that comes first. Post-main. Those are the things that handle constructors and destructors and stuff. Okay. Default temporary data, runtime, custom iterator. Let me get past the preload. These are all preload stuff. I hope there aren't too many. But we're getting bodies. Okay. Let me break, because what I really want to know is the workspace handle, because I want to know. So right now we're seeing procedures from our compile time meta program and not the target program. So I want to break for the target program, which is here. Now it's going to be preload stuff again, though, right? Maybe not. Yeah, no, it's preload stuff. Interp, what is it called? Preload complete. Finished preload. Finished preload. No. Is it on the phase? Finished preload. Okay. So we're going to say the condition is the workspace handle is greater than 1, and interp phase dot finished preload. All right. Finally, we got a real procedure from the user. It's in the main file, and the name I got to look at the casted one down here. The name is handle command line arguments. That is a legit procedure, and we are flagging the body. So, well, it has no notes. We're not doing that. Wait, what? Oh, this is just the... Wait, what? I dropped my is body out of this condition. That was the whole point, was we wanted the body. All right. We have the body of a procedure called init languages. It is the body. We've got a root expression. It's a procedure. It's got no notes on it. 86 flattened nodes. Okay, that's good. So this is working as expected now. So we exported this. Intercepting code is true. Let's see. Let's make sure that flag is on it. Exported. It's a code node. 0. What? I thought the whole point was that we just set that flag there. Okay, is body is true. Oh, it's on the declaration flags, not the node flags, right? Okay, we're looking at a different procedure now because I continued. This one is languages right to left. This is also a totally reasonable thing. We export it. Okay, so we exported it. We're supposedly sending the message. Well, I mean, we'll check that it gets all the way through, but let's also see. So this might be user code error, like I might have done something wrong. Exported. I can look at his declaration flags. They're 128. Let's make sure that's in sync. Is procedure body, that's OX80 is 128. And I have to check the C++ side. Okay, they match. So this is the flag we write from C++, and this is the one that we read. So I am not sure, like, is there some reason why this message doesn't get sent? No. Is there some reason why it doesn't get received? We're waiting for 2,000 messages already. Okay, well, we should be able to print this out and see it from the user side. So again, this lambda was languages right to left, and we should be able to see that with declaration flags of 128. So let's see if we get that. Let's go here. If message dot kind, I'm just going to straight up splat stuff. Well, no, okay. We'll put it in check. So we're here. Oh! I fail so hard. I fail so hard. This is not a compiler problem. Okay, let's talk about how things work in this language. I forgot, I was so tired when I did this. Basically this check for name being null is the problem because we're throwing out the declarations that we want to see. So basically, when you do something like this, so I'm declaring a procedure, I have the identifier, right, and then I have the procedure body. This procedure body is a lambda expression that could be anonymous, right? You can pass a lambda expression as an argument to a function or whatever. So this, when I said before, hey, lambdas have a header and a body, and each of those go through separately, that's attached to the expression, right? The actual declaration that binds that to a name is it's a third thing that also travels through the system, and that the name is bound to the lambda expression, right? So the things that we're looking for that are going to be flagged as procedure body are not going to be the name bindings. Those just bind the name to the lambda. The things flagged as procedure body are going to be these anonymous declarations that are attached to the lambda. And I may have changed that somewhat since the last time when I wrote this comment, which is why it's a little bit confusing. Yeah, so that's why. So there isn't, I don't think, actually a compiler bug here. So now we go check print calls. Let's just see if that works. Hey, look, I see all these procedure calls to clamp and move toward and skin mesh and memset. Wow, it's almost like I can actually look through my program and see what it does. Such a dumb mistake. All right, but that's what we do in programming sometimes. We make dumb mistakes. And that's why we check as we go along to see whether we've made dumb mistakes or not. Look at all those procedure calls. It's almost like we wrote a program that calls procedures, and now we're trying to check it. Okay, so we have this identifier. Now, we should be able to then resolve. So the identifier has a resolve declaration. So by the time we get this information for each procedure, we not only know that this procedure call used an identifier to identify the procedure it wants to call, but we know that what that identifier maps to. So we just say ident.resolve declaration, and I'm just going to print that here. Resolves to procedure at whatever. All right. Oh. Really? Oh. If resolved, let's do that. Okay. I don't know why sometimes that's null. We need to look into that. I think we'll postpone that for now because that could be a legit compile bug. Anyway, yeah. So you can see, we have a call to find pullable at this location, and it resolves to a procedure at this other location in the same file. Sometimes it'll be a different file, right? So this one's in this file, and it resolves to that file. So that's working, except I'm not sure under what conditions that would be null. Oh, yes, I am. If the procedure that we're looking at is polymorphic, okay. Polymorphic procedures we don't want to check, because we can't necessarily have resolved their identifiers or anything, and they don't actually run. Any polymorphic procedure gets solidified into a non-polymorphic procedure. Huh. How do I tell if a procedure is polymorphic? If it has a polymorph source header, maybe. So I'm going to say so, all right. Let me comment out that. Oh, let's comment out that. No, we may not be. So one of the things that's a little bit spotty is I may not be filling out all of this information because we're in a stage of incompleteness. I should be passing that it's polymorphic here. Let's fix that. Because we want that for correctness. We don't want to waste time scanning procedures that, so if, well, let's make sure that we don't set that. Polymorph source header. Yeah, that's commented out because of issues. So we're not going to use that right now, but we're going to say if proc.proc flags and procedure flags, and procedure is polymorphic, then we will say this, else we will say that, and we will say procedure is polymorphic, and we'll go into the compiler. And we'll set that. All right. What did I get wrong? Oh, it's not lambda is polymorphic, it's what is source? Is that a lambda? Yeah. So source is a lambda. I changed the way lambdas are flagged polymorphic recently. If source inferred type def and flags, or no, we can say, okay, we have a helper, is polymorphic function. Yeah. I usually say procedure. Where does this go? Oh, lambda, lambda type. If is polymorphic function source reset that. Let's see if we detect any polymorphic anything. No, don't run the game, compile the game. There we go, detected polymorphic. That's fine. Take a moment now to check chat. Ignore those previous questions. Yeah, okay. I will ignore those previous questions. Any specific reason I compile through Visual Studio? No, because it all sucks and I'm not motivated to try and make any of it better. That's why I'm doing a whole separate thing in the first place. Okay. So now that we know that things are polymorphic and we're skipping them, let me verify Let me verify that that was actually the problem here. I still sort of feel like that resolved, or that assert is going to trip, but let's find out. Yeah. Well, there may be other cases in which, yeah, there may be other cases. So we're going to leave that as a to-do for later. We can get rid of this one because we know that that actually wasn't a bug in the way that I thought it was. But this is an open question. Like, okay, the polymorphic one makes sense. I'm not sure why there are other cases where a resolved declaration might be null. Maybe it's a bug, or maybe it's a legit thing. Have to figure that out. Oh, I just spilled a little bit of tea. Okay. So we're just going to ignore when we don't resolve right now for whatever reason. And then we're going to say, if we did resolve, then we check that. So if it's not print like, then continue. Otherwise, we're going to say we got a print like call. So this is all we're trying to do, is get to the point where we realize that we're calling some procedure that does print, right? So what is print like? Is print like decl is code declaration. Well, yeah, return true. Otherwise, return false. And let's give ourselves something to return. Hey, look, we noticed all these print-like calls. That's great. So, I'm going to make an incomplete here. Well, no. Well, yes. So remember way back, before I changed whatever the old name of this was to check print calls, up here I was like, oh, we're checking for things that are tagged print like, and we shouldn't be doing that. But we probably want to do that separately anyway, because we want to tag that you didn't mark something print like by mistake that took the wrong arguments, right? So if I mark some random non-print function as print like, that would be not good. So I'm going to say incomplete, check all print like routines to ensure that their arguments go the right way. Maybe we'll do that in this stream. Okay. So we got a print like call. So now we need to know, oh dear. So we need to figure out, first of all, what the format string is. And then everybody after that argument will be the variable arguments. Now the format string is not always the first argument and stuff. So we need to say, first of all, I'm going to say index is get index of format string, get argument index of format string from resolved root expression. We're going to assert that that exists, and we're going to assert that its kind, not arrow. This is not C++. This is not C++. Do not use arrows there. Kind is equal to code node kind procedure. Let's make sure that that doesn't trip. Okay, good. So we got a print-like call. We get the argument index of the format string. Because we know that's a procedure, I'm going to cast up to that. In reality, I could cache this information because we're going to be re-looking this up every time we do a print-like, but it may be faster just to recompute this than to cache it. You would have to like have a story for, oh, we could cache it in a hash table. It would probably be a little faster. I don't know. I'm not going to worry about it yet. We're going to make it work. So we got to do this. And now what I'm worried about, well, what I'm worried about is that we're not going to be able to use this correctly unless the compiler gives us more information, but that's one reason why I'm doing this exercise. So let's do this. Get argument of format string is proc code procedure returning an int returns -1 if we fail to find it. So what we're going to do is we are going to, for now, we're going to say, okay, the last argument had better be varargs. And then the argument before that had better be a string, and then that is the index that we're going to return. Well, really, okay, no, because that can go in the checking. That stuff, making sure the last argument is varargs and that the string, that can go in the checking of the print likes that I talked about before. That's a separate problem. So here, it's just the argument before the last one, right? So we check validity of the print likes argument types elsewhere. Here we know that the varargs are the last argument and the format string is the argument before that. So if proc.arguments.count is less than 2, we return -1 because there's just not enough arguments. But I'm going to assert that that doesn't happen. We should have caught this elsewhere. Although, yeah. I think we're guaranteed to visit these in order so that we would have caught the error elsewhere. However, okay. So that's going to be a mildly complex issue. Okay, so we just return that. So that'll be format string index is whatever. Yeah, so most of them are going to be 0. The log prints are probably 1 occasionally. Well, there's one that's 2. Oh, because really? This is a little different from what I would have expected. So I'm going to investigate to make sure that's right. All right. Print, line 287. Okay, so that's this special version of log print that takes the 2 arguments on the front and then the format string. So argument 0, argument 1, argument 2, right? What I'm worried about is that we call the other log print, we call this one a lot. And this has format string as number 1, and I don't see this is at line 280. No, I'm not printing where it resolves to. Ooh, let me see. I suspect there may be another bug here. Print like ident whatever. Yeah. Ident name. I don't see any log prints in there. There's a long log print, but where's the, like I call log print one word all the time. Maybe, oh, no, there it is. Oh, that's the other log print though. Like what? Maybe this has to do with that unresolved identifier bug. Maybe for some reason the other log print is undeclared. So let's do ident file name, ident line number. A lot of unresolved. Whoa, Nelly. Okay. Right. Okay, these are all initializers and constructors. And construct array is polymorphic. Or no, it's value bake requiring. Okay, so let me output that to a file. I'm looking for a log print one. Wait. Wrong output.txt now. Log print one word, so there's that one. This is bugging me. Don't I call that like all over the place? Yeah. All right, well we're going to investigate that separately about why, I mean, unless it's something really dumb, like I misspelled print like. print like. It looks like I didn't. Right? Print like. Okay, well, we're popping that on the list. Why do we not see any calls to log print the 3-argument version, though it is tagged as print like? That is a good question. It might be user error, it might be a compiler bug, it might not be either. It might be just some kind of complex interaction that I haven't accounted for yet, so we will see. But we'll make this work on everything else first. I'm not sure why a lot of those mem copies were unresolved and whatever. You know, I do know. Like we saw a lot of ini and con and memset, so it's all like construct here is supposed to be polymorphic, and maybe something is happening where it's not getting flagged correctly. Anyway, the joys of writing a compiler is you get to start to think about several dimensions of problems all at once. Yeah, I check the chat on rare occasions. If you address on-topic questions directly to me so that it highlights my name, then I'm more likely to see them. Please on-topic questions about this subject only right now, though, so that we don't derail. Because we certainly have enough issues already. Okay, so here's the other thing, which is I'm not sure that I provide so I give this array of arguments. And I guess that's post sorting. One way or another, more work has to happen here. But it might be sufficient for our purposes right now. Let me see. Okay, so this is sufficient for our purposes. The question was, what are these arguments, right? Are the arguments in the order that they're written in the program text, in which case they might include like, oh, I referred to some arguments by name and whatever, and they're getting reordered and stuff, in which case then we would have to sweat about that or have the compiler provide more information now. This is not. This is the arguments after they've sort of been put in order, like decoded at the calling site to match what the procedure actually wants, resolving all the argument names and all that finicky stuff. However, the problem there is we are not providing the original information to the meta program. So the meta program can't ever know how these arguments were expressed originally. Like maybe they were passed by name, right? Which, if you wanted to rewrite the procedure and resubmit it may interfere with things. So I'm going to make a note of that. I'm going to say code procedure call does not provide pre-sorted arguments, and this may be a problem when rewriting and resubmitting program code. Okay, but it's fine for us right now. Yeah. Oh. Need some more chocolate. I'm going to assert call.arguments wait, if index is 1, we're 0 based, so if index is 1, that means we have to be strictly greater than index. Okay, that didn't trip, that's good. So I'm going to print format string is whatever So, I'm going to call it expr for first. So this is whatever expression is given at that argument index. Resolve dot now call I guess I don't need this assert because array bounds checking will act as the assert here. So there are many cases of what might be passed here. We might be passed a variable, in which case we can't check this call right now. But we might be passed a literal string. So we want to check to see if the kind is a literal. If expr dot kind is not equal to code node. You know what? We're doing so much code node dot kind. Get rid of that stuff. Is not equal to a literal continue. Format string is cast to a literal expr. A literal in programming language jargon is just like something that's a very simple constant expression of some kind, like the number 0 or the number 13.5 or the string hello, right? Those are literals. It's a weird name for them, I guess, until you're used to it. So we have the literal. The format string, format literal. What does literal look like? And we're going to assert. So type checking should have caught this, and we should have never made it this far if the literal was not equal to literal string. Format string dot string value. Well, hey, look at all these format strings that we found. That's great. That's great. It is so great. So, next we say number of percents is count percents in the format string. Yes, I am programming. I'm trying not to play video games during work hours and get real work done instead. Is there a reason why I'm including this code in a separate check file and not in print? The reason is because this file is not just going to be about checking print. It's going to be about checking your program for all kinds of things that may or may not be bugs, right? So checking the arguments to print is one kind of compile time check that you may want, and there will be others. Someone is asking about value semantics. No, we don't have copy constructors in this language right now, and probably won't. Assignment is a move, yes. It's like C. It's like C, assignment is a move, and that is that. All right, so from left. So we're going to find a character from left. This is confusing. I'm just going to call this version 2 of this procedure. What is substring? For number of bytes. Return substring. Cursor plus 1. And s.count minus cursor minus 1. I think that's right. So the first thing we're going to do is we're going to count all the percents, ignoring that double percent is not a percent. All right. Count is 0. Remainder is s, while remainder remainder found, remainder found equal find character from left v2 remainder and if found, count gets incremented. Wanted string given code literal. Count percents dot string value. All right, so let's print out we are printing the string value and the number of percents. Okay, 1%, 3%, 3%, 3%. Let's find one with a double percent. I know there is one. There's one. says 7, but it really should be 1, 2, 3, because those just mean to print the character percent, and those just mean to print the character percent. So, and that one says 3, when it really should be 1. So now we detect the following. If found, we call that percent does not count as formatting percent, but so we don't count those. If remainder.count and remainder sub 0 is equal to another percent, otherwise we do that. We've got to skip over the second percent otherwise. All right. So let's go find one of those multis. Where were they? Where? Okay, there we go. So this one has 1%, even though there's, 3. This one, it said 7 before, now it's got 3, so that works. Hooray. So, that sounds good. And now we just check that versus the number of arguments. Right, so if, well, oh gee. Okay, there's another complexity that we're not going to handle yet until we get an error message and user code from it, which is there's 2 ways to call a varargs procedure, right? You can just pass the arguments in the end, which is fine, or you could spread an array in, which is, in which case that would only be 1 argument, but it's also probably not checkable in almost any case. So that's also going to be very rare, I think. And I'm pretty sure I never do it in my own code, but we should detect that in the future. So I'm going to put incomplete, detect the case where we call one of these guys by spreading the last argument. Actually, maybe I can do that very quickly. Yeah. So if the last argument is spread, we can't know for sure how many. Okay, so way back up here before we do any of that other checking, so we're going to assert call arguments count is greater than 0, because otherwise we should have errored out in the compiler's regular type checking. If the last argument dot flags, is it called flags? Node flags. We just ignore it. Ignore anybody with a vararg spread. So that's fine. We still see all this stuff. Great. Great. Okay. So we'll just say number of arguments, number of varargs is call.arguments.count minus whatever the index was, minus index, I think minus 1, right? So if there's 1, no, yeah. Okay, we'll find out if that's right in a second. If number of percents is not equal to number of varargs, I have an official way to, yeah, compiler report error. Compiler report error, call.filename, call.line number, call.character number, well, error string. All right. Error string tprint incorrect number of arguments supplied to whatever the format string requires whatever arguments but you gave, well, but argument are given. We'll fix that parenthesis s stuff in a minute. Ident.name, number of percents, number of varargs. You're telling me I didn't make a mistake anywhere in Sokoban? All right, let's put that to the test. Well, people certainly caught the mistakes on the stream and stuff. Let's go here. And one thing that often happened was I would forget the handler.line number, right? People called me on that several times. It didn't catch it. Are you kidding me? Is compiler report error not? So I'm not surprised at that, because as soon as it said there were no errors, I was very suspicious. Weird. What? Oh. No, this is, okay. We established before that log print for some reason was not getting handled. So let's look for a different one. Let's look for like a tprint or something. Tprint. I know I've got some tprints around here. How about Sokoban? Tprint. Okay. 15. I added an extra argument to tprint. See if that. There we go. Incorrect number of arguments supplied to tprint. The format string requires 2 arguments, but 3 arguments are given. Okay. Now I'm going to do one of those things that's a little bit goofy. Okay, if number of percents is equal to 1. Well, okay, so percents string is one argument. If it's greater than 1, is tprint arguments, comma, number of percents. We're going to do the same for the other one. Now, this is the kind of thing that changes a little bit based on what language, but, you know, it's a common thing. That singular and plural are different. If you want to localize to some weird language, this code might have to get more complicated. But the one argument is given. Percent arguments are given. So in English, given is the same, but in other languages like Spanish or whatever, this whole phrase would need to swap out. And so number of varargs yeah, that's fine for now. Okay, requires percent string vararg string. Okay, there we go. So that's good. We have more error checking. Line 1501, yeah. Let's do this. Requires 2 arguments, but 1 argument is given. Great. So that's enough for a check-in right now, but then we got to figure out like why log print is not happening, because I call that all over the place. What did we added flag polymorphic procedures, right? At least. Oh, I guess we already checked that in. So this is good. This is like solid. You know, I usually check in an LLVM version for everybody else because that'll make faster code. So I'm going to recommit that. Does this also catch 0 arguments? Shouldn't it say X arguments were given? I don't know. I think of it as a present tense thing. Okay, let's test the 0 arguments thing. So here, that should work. Oh, weird. Right, okay. Goofy. So I got it slightly wrong, right? It should not be greater than 1. It should be not equal to 1. Because if it's 0, in other languages, 0 might be singular, or you might require a totally different phrase. Whatever, we deal with internationalization later. But there we go. Okay. Okay, I'm going to take a tea warm-up break. And when I come back, in just a couple of minutes, we are going to figure out why log print is not coming through, which may involve more compiler debugging or something. Or maybe we'll decide it's user error. So, resuming in 5 minutes. or so. Okay. Well, let's see what to do here. Why? So first of all, let's see that we are, like, we should see many calls to log print throughout the code, right? One of them is to the 3-argument log print, and we're already catching that. But most of them should be to the 2-argument version, which we're not catching for some reason. That is some kind of bug or another. So, well, we'll leave that. So if call.ident.name is equal to log print, number, found log print call there. So we should see a lot of those. Whoops. This is just ident. Yeah, we see a lot of log print calls. A lot of log print calls. So, well, let's make sure we got it resolved for most of those. Yes, it is resolving to one of 2 procedures, right? So one of these is the 5.8 is probably the multi-argument one, and the 6.8.0 is probably the 2-argument one or something like that. See that? See that? Almost all of them are to the 6.8.0. Okay, so if resolved for resolve.notes, note blah it. Yeah, this is problematic. Maybe the notes, so either the note is not getting copied correctly, or not getting exported correctly, or it's ending up somewhere on the syntax tree that it shouldn't be due to some weird reason that I'm not sure why that would be. But yeah, so once we look up the resolved, declaration, we should see that it's a print like. Okay, now we can also do the converse version of this, which is the following. Remember, we have our to-do up here that we want to check all print likes. And so we could do that. If is print like decl incomplete, check print like validity decl. Okay, so these are all our print likes, and we're printing it out twice because we're printing it out once for the header and once for the body. And we're going to do this. What are notes? Okay, hold on. Compiler. Oh, that's an array of code notes. So we could just do this. Well, it always has a note that says print like, always. Which I guess is no surprise, because is print like looks for a note to see if it's print like. So let's actually print the identifier. Do we have it? Oh, we just have the name. So I believe log print will be in there. Oh, I'm not setting the name always. The name's probably set on the header and not the body, or vice versa. Or on the lambda. Oh, because the lambda notes are getting copied onto the deck. That's a whole step that happens. So what's happening is these ones with empty names are the lambda header and body, and these are the bindings of the name to the lambda, which is fine. Because I think that's all we need. So we have both log prints. We have a 265 and a 274, right? So print line 265, right, is this one, which is the one we want, and then 274. So now, is it possible that we're not getting these in the right order somehow, that the note isn't exported and attached? So I'm going to do this. No, we got the log print, and we got the other log print before we got any of the calls. So somehow the resolve doesn't have no. Oh. But why would that be different? There's an extra whole thing about import declarations that have to do with namespace management that I suspect is coming into play here. Well, let's get that parenthesis in play. Right. So these are actually not the same declarations. And I think it's because we're giving people the import stub that gets you from global scope to file scope. Okay, so let me go into message. I had thought, let's just see if this helps. While actually, now let's just say So my theory about what's going on is that we're getting the import target, but I want to be wrong about that. Because that, oh, import link. I changed the name of this a while ago. Link. See what happens there. Oh, you're kidding me. Okay. So, clean up. I don't know why we are setting resolve declaration to the import link, but probably for simplicity purposes, we should not do this. And we'll put that in our to-do list. And then we'll do this. If anyone wants to know what the hell is going on there, we could talk about it in Q&A. Let's see if that actually fixes the problem. No, it doesn't appear to. Oh, right. Because we have to actually then use that. Okay. Yes. Yes, now it's working. Incorrect number of arguments to log print. The format string requires 1 argument, but 0 arguments are given in. Dude, that's a legit bug. That's not one of the ones that I introduced on purpose. That is vars line 187. Log print agent. Error in line whatever. String value must end with a quote. Line number. I knew there would be an actual bug. All right. Get rid of all that silliness. (4:05 p.m.) The assert is still there. Which assert should be firing? Which assert do you mean? Which assert do you mean? Assert not declaration target link. Oh, thank you. That is very careless of me to check that in without doing the debug build. Yes. That should be taken out, obviously. All right. So if we had run that in debug build, if we'd run the compiler in debug build, it would have asserted because it likes to assert. I like the fact that at least one person is paying at least a little bit of attention to what is actually happening as opposed to just letting the stream of verbiage wash over. Okay, So that is good. So why don't we move on to that thing that I put at the top of the file about, hey, we should validate that when you mark something as print-like, because people may make their own print-like routines, that's not an unusual thing to do, that when people make their own print-like routine, that it conforms to this format. Okay. So. Right. So we did that. I'm going to call this validate print like. So we'll put this at the file scope. Delete those old comments. So validate print like. For now, we'll just return true. Let's make sure that compiles. Hey, great. So now we have to actually validate the print like. So what were our rules again? It's got to have at least 2 arguments because one of them is a format string and one of them is the varargs. Last argument has to be varargs. The argument before that has to be string. So if decal.arguments.count is less than 2, compiler report error. Decal file name, decal line number, decal character number, error string, right? So error string is tprint. Declaration is tagged print like, but has fewer than 2 arguments. Right. Okay. Return false. Okay. How do we know if something's varargs? Oh, decal doesn't have arguments. What am I smoking? What am I smoking? Okay. If expr.kind is not equal to procedure, Then we say, but is not a procedure. Well, we don't need to t-print that. We just do that. Okay. So we cast to code procedure, and now now we have arguments and returns and all that stuff. I don't know if we export the fact that it's varargs or not. Let me look in Messenger, see if I do that. Varargs. Nope. All right, so we need to communicate that information. But we can at least, until we do that, so I'm going to put an incomplete. Check that it had better be varargs. But it had better be last decal lambda dot arguments dot count -1. So this will have this thing called a type inst, which says what type it's declared as. So we're going to assert last decal that type inst is not equal to null. So I'll say inst is that, and we'll assert that inst is not equal to null. So now oh, well, we have the non-varargs argument. Oh no, we're looking at the inst for the, we're looking at the, yeah, it's different. It's different. This has to be root expression. I'm making all kinds of goofy mistakes. So we have some type inst, and we want to say that it's an array, because that's what varargs are. They're an array that's flagged in a certain way. So we just want to check this. So if inst.array element type I'll do this one. All right. Otherwise, I don't know if I want this to be decal. I might want this to be lambda. I don't know. Procedure, say procedure. Yeah, let's make it lambda. Okay, and now format string decal is, whoops, this okay. So, if format string decal dot type dot, so now we're in a type info here. So it's dot type dot type is not equal to type info tag dot string. Then we say but it's, this is going to be a crappy error message, but it's next to final argument is not a string. Let's see if that compiles. Nope. We don't want to use compiler message that kind. We want to use, yeah, code node that kind. I was using the wrong thing. Its final argument is not varargs. Okay. I guess maybe it's not an array. Yeah, I guess it doesn't get exported as an array. What does it get exported as? Let's find that out. Print oh, right, because it's null. Duh, no. Inst. Okay, so it's got a type, what? How is that right? I don't think this is right at all. These numbers are all incorrect. And how is the type name printing out as an integer? Do I do that in failure cases? Oh, it's a pointer. Yeah, so okay, no, this is coming out wrong because we're not correctly using code node. That's crazy that that's been going for that long. So this one is correctly, okay, so, well, okay, so maybe this was only happening because it was wrong, but now it's saying next to final argument is not a string. What? What are you talking about, man? Next final. We'll print the inst in that case as well. Okay. This does not look corrupted. Well, Whale. I want to print the type. Print type is... Oh, I'm printing the wrong inst here. I'm so tired. It's void. Why is it void? Why do you think it's void? That's weird. That is weird. I'm confused by this. Name is format string, but it thinks the type is void. Why do you think that? Why do you think that? It's pretty obviously a string. It says it's a string. We're making just a really dumb clerical error. Format string decal dot type dot type. I think I have to step into the compiler again. I don't have ideas right now. Maybe it's just because I'm tired. I do not. It's the right declaration because we're printing the name. So I really let's look at the serial. So let's make sure that so it's that number. Let's make sure that's oh, it's not. Oh, it's no jobs it. Okay, so the serial is the same every time when we no jobs it. So what I'm going to do is break in the type info export. Let's make sure that number is the same in the debug build of the compiler. Should be, but I'm not sure. Okay. That's a separate thing we can look at. It might be related to what we're doing. But the number is the same. That's all I really care about right now. So, do I actually don't want the let's just go to the top of this file and search for declaration. We're going to say source x serial is equal to that number that we copied. I probably have some other breakpoints hanging around that we're going to get rid of because they just slow us down and are unhelpful. All right. So source inferred type is, well, let's see if it's void. No, those are different numbers. So how are we ending up with void? It's some kind of mistake. Look, it's string. It is string. It is string. Interp type def string. Look, it's the right type. So what the hell is happening? Wait, what? Why are we just setting the type? Right here we're setting it to void. Why are we doing that? How does that make any sense? What the fudge? Why would I ever do that? That makes no sense at all. It makes no sense at all. So result is a code node, source is an AST expression. Well, at least that's an easy one to find. Question is if there was a good reason for that, or if that was just, like, some things are just so old that the concept of how the compiler worked and what it was supposed to do is just really different. So let's see. I don't think we export type here. We export type inst, but that's a different thing. Okay, wait. I believe it should already be filled out, and we were just stomping over it for some reason. Let's find out if that's true. Someone's asking, that code is dealing with lambdas. Do function definitions get modeled as having a lambda RHS? Yes, all procedures are lambdas, and all of normal function declaration is just binding a name to that lambda. Okay. So result, code node, type, it's string. Why was I stomping that with void? Can anyone tell me why long ago, I put that line in there. Does anyone have any idea? Hey, look, it worked. If you don't explicitly put the wrong information in the node on purpose, then it works. Okay, so we have two things to do. One thing is I'll make a couple little test cases. I'll make a couple little test cases that are tagged print-like just to exercise this. So, so it should catch that right away. That should be fine. That should be fine. All right. So, now, the thing that has to happen is that we must correctly be able to check for varargs, which means the compiler, oh, let me check in. Am I making it void because I wanted to get rid of it after doing whatever exporting that export function does? No, I think it was just some kind of mistake. I don't know. I can't even imagine what that was. Yeah, I could search the commits, but I don't want to. Yeah, I mean, I couldn't tell you what it was. Couldn't tell you. Does the checker handle multiple varargs? You cannot have multiple varargs right now. You cannot declare a procedure with multiple varargs. It's probably something that we could handle because with named arguments, you could do that. But we don't do that right now. Didn't consider it particularly important. Okay. Well, varargs have to be declared with a type instantiation. So that is the thing that would be flagged. So let me look at how I do it internally to the compiler. So we have type definition, okay. Yeah. All right. Okay, so we can just go like this. This is not going to exactly match the way that I track this internally, but that is fine because we want a layer of abstraction between the compiler internals and what people see. So I can say inst is varargs, right? And that'll be on, oh, but we already have, we probably need this. I'm not sure if this is the right way to do it, but we'll do it. Instantiation. What? There we go. If source defin flags type definition is varargs, result defin flags is code type definition. This is probably something we'll simplify later, but whatever. We're just getting the information there right now, and later we'll determine the best way to simplify the information to make the best API for people. So type definition is varargs. So we also, on the import, we have to do the reverse. This is import, right? Yeah. All right. So that didn't kill us. Now, go back here. If hey, that worked. Now, let's go into here. So that's going to complain that we have fewer than 2 arguments. So now, that's good. But now if we do this, it should complain, hopefully. Yes. All right. Final argument is not varargs. So that is good. That might be the end of the stream in terms of practical use. Of course, this morning I was very ambitious and said things to do today, and we only got the first one, which was the print statement. So we can do more of these things later on, I think. It'll be a future stream. Future stream. Most of these should be easier than the one that we just did because, you know, cross-referencing data at the calling site and the callee site is just, it's a slightly more intricate thing than just looking at one site and saying, is it this kind of expression or whatever. So I think we picked the hardest one to go first. Someone is asking if I considered using another file format. I have a rant. If you watch those videos, I have a rant about how I don't want to use any such file format. I don't care which acronym it is. I'm not going to repeat the rant, and it's off topic for right now. No, you guys, okay, people are speculating in chat about why I don't give out the compiler. Look, the reason I don't give it out yet is because A, it's not done, which B means that if people start writing code in it, their code is going to get thrown out later when the language changes substantially. Now, at some point, we're going to have automatic rewrite facilities so that if the language semantics change, you can automatically upgrade your code, but that is highly speculative and doesn't exist yet, and who knows, right? So 3, there are definitely still some bugs left, which, as you've seen today, anytime I haven't gone into this territory of using compiler messages in a long time, and because I haven't done that, then the bugs in that area have not been revealed. So I revealed many of them and fixed them, guaranteed that there's some more left in there, right? And so when there are bugs like that, you don't want to waste people's time, because if you have a bug in the code and 100 people try to use it, and each of them loses an hour of time, then you've wasted 100 hours of people's time on something that you probably could have fixed in an hour or less. It's a massive, it's an ecological disaster is the only way to think about it, all right? And I think, you might say, well, open source projects do this all the time, and that's one reason why I think most open source projects are terrible. They're just awful. So I'm not doing it that way, all right? If you've never done a programming language before, you might be tempted to think that you just want to get something barely working and release it to the world because that's better than nothing. And the reality is it's not really better than nothing. You have to make sure your thing is good so that it's worth people's time, really, right? Really worth people's time. And so I'm making sure that that's happening, and that's why I'm not giving it out yet. It has nothing to do with I don't know, whatever speculation was happening that I just read in chat that made me annoyed. How does a checker respond to spreading varargs from an array? We skip any spread. We did that earlier. So this thing, if the calling site tries to spread anything, we just ignore it. We say, well, that's just not something we handle. Did I rework how SOA works? Not yet. That's on the table for later. Well, this may be my last programming stream for the day. It's good. It's good to have gotten this down. It feels good because now there is some code in one of the tick boxes that I wanted to have, which is, example in the standard library of compile time checking that people can then be guided by in implementing their own. So it's good to have that. Like I said, it's going to get expanded in a later stream to include some of these things at the bottom, but it's a good start. And I'm pretty sure I chased down at least 4 different compiler bugs in the process of making this work. And that's a guarantee that there's probably at least 4 more, right? Maybe 3 or 2, but I would guess 4 more hiding somewhere. That'll be revealed later on. And that's is what it is. How do you test your compiler? Well, I don't really test it very thoroughly yet because it's not being released. So, when you release things, you have to test them rigorously if you have any personal ethics of software engineering, right? Now, again, most open source people don't, but that's beside the point. So, what I do right now is I make sure things work well enough for our current project. So like if it compiles Sokoban and Sokoban runs and maybe one or two other things run, that's a good enough test for now because those programs exercise many parts of the system. It's not a perfect way of doing things remotely, but it's an efficient way to split the goals of not breaking things with making rapid forward progress, right? If you spend too much time testing, then you don't make rapid forward progress. I do want to build more of a formalized test suite pretty soon, but that is not there yet. Someone is asking if my book on internet game programming is still relevant. That book does not exist. That book never existed. I maybe started writing a rough draft of the first few chapters and then decided not to do it. So any entry that you see claiming that that book exists is fictitious. All right, everyone. Thanks for coming by. If you missed part of this, it'll be up on YouTube later, and we will continue this stream later on. We have at least a few different topics now to do streams. So there's continuing the compile time checks. There's the order-independent animation blending on expanding the animation system and fixing the discontinuities and maybe adding smooth step for style purposes. I actually fixed off-stream many of the little weird interactivity bugs that were in the Sokoban game about flipping back and forth between the editor and the game mode and the time dilation and stuff. Those didn't seem important enough to stream. Most of them were just a couple minutes each. There's adding runtime logging for print when it detects at runtime that it's got the wrong number of arguments, because this compile time check that we did cannot cover all cases. And then there's debugging that non-determinacy that I was seeing when I was trying to debug that earlier compiler problem. So in theory, when I run the compiler with no jobs, the no jobs option, then everything should happen the same every time. And it clearly wasn't in that case. And that is not necessarily a good thing. So I want to see if I can figure that. That might be just an interesting debugging session all on its own. So there's so many streams to do. I don't even know how we're going to do them all. All right. See you later.